Hello guys, today I want to talk about scientific notation. Basically, this is a method that we use to represent numerical quantities that are either very small or very large. The reason for that is that we don't want to be writing too many zeros in any quantity just to express how large it is. I want to present the basic logic first, and then some rules that we follow to make this a standard representation. Let's start with the basic idea. In this first example, we want to represent 40,000 as the product of a small quantity, say between 1 and 10, and some power of 10. If you look at this number, 40,000, you can see that it can be written as the product 4,000 times 10. Following that same logic, it is equal to 400 times 10 times 10, or 400 times 10 squared. Observe that for each power of 10 that we include, there is one less zero in the quantity to the left. Therefore, we can determine that for every decimal position that is occupied by a zero, you get a new factor of 10. Under this logic, the quantity is equal to 40 times 10 cubed, or 4 times 10 to the fourth power. This is the standard notation that we are looking for. We want the number to the left of the multiplication sign to be less than 10, and we want that number to be multiplied times a power of 10. Next, we are going to discuss some of the nuances of this procedure, because not all numbers are as round or as nice as 40,000. So what do we do if we have more than one digit in our quantity? In that, we can follow the same logic as before. The given number, 497,000, is equal to 49,710, or 4,970 times 10 squared, or 497 times 10 cubed. However, we can continue by thinking that any new power of 10 can come from displacing the decimal point one more space to the left. This is equal to 49.7 times 10 to the fourth. And following that same logic, you can move it one more space, in which case you end up with 4.97 times 10 to the fifth power. Once again, the number before the multiplication sign is less than 10. What do we do, however, if we have a very small number? In this case, the decimal point is located to the left of all the significant digits. This means that you actually need to move the decimal point 4 spaces to the right, not to the left. It is 4 spaces, because you always want a non-zero digit before the decimal point. If you want to move the point even one space to the right, you need to consider that moving the decimal point implies dividing by 10. So this number is equal to 0.00967 times 1/10, or what is the same, 0.00967 times 10 to the negative 1. By that same logic, the number is equal to 0.0967 times 10 to the negative 2. So, for each space that you move the decimal point to the right, you are decreasing the exponent of 10 more and more into the negative numbers. This is the same as 0.967 times 10 to the negative 3, or 9.67 times 10 to the negative 4. Summarizing, if you move the decimal point n spaces to the left, you must increase the power of 10 by positive n. If you move the decimal point n spaces to the right, you must decrease the power of 10 by negative n. The reverse is true if you have a number in scientific notation and you need to bring it back to standard notation. This one has an exponent of 5, which means it is multiplied by 100,000. That means moving the decimal point 5 spaces to the right. If, like in this case, you run out of positions, you need to add zeros. The given quantity is equal, then, to 467,000. On the other hand, if your number has a negative exponent, it means you need to move the decimal point so many places to the left, not to the right. Almost always, you need to add zeros to fill those spaces, plus one extra zero before the decimal point. The given number is then 0.006. This process is the same even if you have more digits in your quantity. Look at this final example. The decimal point is right after the 4, and the exponent is negative 5, which means you need to move it 5 spaces to the left. Therefore, this quantity is equal to 0.0000417. I hope you find this explanation interesting and useful, because you will find scientific notation time and again during your physics education. Thank you for your attention, and I look forward to seeing you soon.